You might think advanced math is a recent invention, but what if the very foundations of modern computing were laid centuries before computers even existed? This video will take you on a mind-bending journey to the medieval era, revealing how brilliant minds developed algorithms that are still surprisingly powerful. Get ready to see the past influence your present in ways you never imagined. That it's easy to dismiss the Middle Ages as a time of superstition, stagnation, and intellectual slumber. The very phrase Dark Ages casts a long shadow, implying that the lights of reason and science had been extinguished for centuries. But this idea is a myth, a modern narrative constructed from misunderstanding and bias. Because beneath the surface of plagues and wars, there existed a vibrant undercurrent of inquiry, experimentation, and, yes, mathematics. Walk into a medieval scriptorium, and you might not see flashing screens or humming servers, but you'd witness something else, a kind of disciplined obsession. Monks hunched over illuminated manuscripts weren't just copying words. They were preserving logic, geometry, and numeric systems that came from far beyond their own shores. They were decoding the universe with ink and parchment, many of the tools we now associate with the digital age. Algorithms, computation, abstraction have roots tangled deep in this pre-modern world. In fact, the word algorithm itself comes from a 9th century Persian polymath, Al-Khwarizmi. His treatises on algebra and systematic problem-solving passed through Arabic, Latin, and finally into European consciousness, long before any Renaissance. Thinkers claim the spotlight, but let's not get ahead of ourselves. First, we need to challenge the narrative that the medieval mind was primitive. Consider this. Some of the algorithms written in the 12th century were so efficient that they rival the ones used in modern coding instruction. These weren't just theoretical puzzles. They had real-world applications, measuring land, calculating taxes, navigating trade, and constructing sacred geometry that rivaled the complexity of any modern blueprint. What kind of mind does it take to imagine numbers not just as symbols, but as living patterns? What kind of society cultivates that kind of thinking? To answer that, we need to step into the shoes of a medieval mathematician. And not just any. Imagine you're in the monastic cell of a 13th century scholar, trained not in universities, but in cloisters. You don't have paper as we know it. You rely on hand-copied texts, often incomplete or warped by translation. Your candlelight flickers against walls covered in geometric sketches. And yet, you are determined to answer profound questions. How many days must pass for Easter to fall on the right moon? What is the shortest distance between two cities, factoring in the curvature of old Roman roads? How can I divide land fairly among heirs while respecting feudal customs and astronomical omens? In this world, math isn't just arithmetic. It is sacred order. It's divine harmony made visible. And so we begin our descent into the algorithm's cradle. Long before modern banking or coding languages, trade routes snaked through Europe, North Africa, and the Middle East, carrying not only silks and spices, but ideas. In bustling ports like Venice and Cordoba, numbers became more than counting tools. They became weapons of prediction, instruments of power, and maps to the divine. Merchants needed conversion tables to trade across currencies. Astrologers needed ephemerides to chart the heavens. Builders needed ratios to align cathedrals with solstices and cardinal points. These weren't random tasks. They required systems. Systems built on logic, and logic, in the medieval world, was tied to something greater than pragmatism. It was tethered to truth itself. Consider the Gothic cathedral, not merely a structure of stone and glass, but an encoded algorithm. Each arch, each spiral, each golden ratio etched into the architecture served as a physical manifestation of the divine order. These buildings were not only engineered, they were computed. Using what? Not calculators, but human minds trained in inherited traditions of geometric reasoning. traditions passed down from Euclid, reinterpreted by Islamic scholars, and resurrected through Latin manuscripts in the Islamic world. Scholars like Omar Khayyam were solving cubic equations geometrically, while Jewish philosophers like Abraham Bar Haya wrote early treatises on algebra in Barcelona. These thinkers shared not a language or religion, but a dedication to numerical truth. And within Christian Europe, the thirst for mathematical understanding merged with theological imperatives. To calculate the date of Easter was not merely academic, it was salvific. Time itself had to be harmonized with Scripture, which meant moon cycles, solar patterns, and algorithms scribbled into the margins of Bibles. Medieval scholars weren't inventing math in isolation. They were translating, transforming, and transmitting knowledge from every corner of the known world. They were reawakening the buried bones of Babylonian tablets and infusing them with theological gravity. But beyond theology, math became power. In the court of Charlemagne, reckoning tables were used to determine land boundaries and military logistics. In Italy, early banks began using double-entry bookkeeping, an abstraction so brilliant it still underpins the global economy. And in the East, Hindu-Arabic numerals, far more efficient than cumbersome Roman ones, began their stealthy invasion of European consciousness. All of this culminated in a figure many reduce to a simple math riddle. Fibonacci, that you've heard of, the rabbits, the spiral, the famous sequence. But that's only a fragment of his brilliance. Born Leonardo of Pisa, Fibonacci traveled extensively through North Africa and absorbed the mathematical traditions of the Islamic world. When he returned to Europe, he didn't just introduce new numbers. He introduced algorithm, the very act of performing calculations systematically. His 1202 work Liber Abyssai is more than a math book. It's a revolution hidden in plain sight. It explains how to compute interest, convert currencies, and even calculate square roots, all using a positional number system so intuitive. It's the basis of every digital device we use today. Yet, despite his contributions, Fibonacci was not a celebrity in his own time. His work was absorbed slowly, often silently, by a continent still suspicious of Arabic influence. Even the term algorithm, drawn from Al-Khwarizmi's name, became a ghost, morphing into the modern algorithm, stripped of its historical roots. And so the pattern continues. Knowledge preserved by the few, misunderstood by the many, and repackaged, in each generation under new names. But those medieval scrolls, those forgotten treatises, they remain as proof. Proof that computation isn't modern. It's ancient, sacred, human. By the time Fibonacci's Liber Abyssai began whispering through the libraries of merchants and monks, the mathematical awakening of Europe was no longer just a revival. It was an unfolding evolution. And yet, what's most astonishing isn't simply the techniques these medieval scholars developed. It's the environment in which they achieved them. Imagine trying to solve complex arithmetic with no standardized textbooks, no streamlined symbols, and certainly no calculators. You're working with wax tablets, abacuses, or at best, sheets of vellum, painstakingly hand-copied with quill and ink. Errors were costly, revisions rare. And still, from this primitive setting emerged a level of precision that seems almost otherworldly. The hunger for precision was everywhere. In the bustling trade cities of Florence, Bruges, and Constantinople, calculation became survival. Merchants couldn't afford guesswork. An error in exchange rates, in weights and measures, in projected yields, that was the difference between profit and ruin. And so the marketplace itself became a crucible for algorithmic thinking. What emerged was more than math. It was structure. Formulas to predict seasonal yields, tables to navigate long-distance trade routes, techniques to calculate interest over time, centuries before compound interest became formalized in modern banking. But it wasn't only trade that fueled this wave of innovation. Across the sacred landscapes of Europe and the Islamic world, cathedrals and mosques were rising. Massive structures carved from stone, yet born from number. These weren't arbitrary designs. They were coded with geometric ratios that aligned with astronomical cycles and philosophical ideals. The very architecture became an algorithm carved into the earth. In the Islamic Golden Age, centers of learning like Baghdad's House of Wisdom weren't just repositories of ancient texts. They were incubators of abstract systems. Scholars like Al-Tusi, Al-Karaji, and Al-Kindi refined algebra, trigonometry, and algorithmic logic with a level of abstraction Europe wouldn't match for centuries. These ideas flowed westward, sometimes translated through Hebrew into Latin, sometimes arriving via merchants, diplomats, or war. Meanwhile, in Christian monasteries, another form of algorithm was developing, one less abstract, more ritualistic. Computus, the calculation of the liturgical calendar, was a mathematically complex system for determining movable feast days like Easter. It required understanding lunar cycles, solar years, and leap year corrections, all without a uniform calendar or modern astronomical tools. To calculate time itself, medieval scholars invented models and rules that eerily resemble modern programming. Conditional logic, nested operations, cyclical adjustments in the shadows of abbeys and under candlelit domes. A quiet code was being written, but some minds reached even further. Enter Nicole Oersma, a 14th-century French philosopher and mathematician who began sketching what we might now call coordinate systems, the very logic upon which René Descartes would later build analytical geometry. Oersma visualized time-dependent phenomena, like acceleration, as mathematical graphs centuries before the Cartesian grid existed. What Oersma and others were doing wasn't just applying math to the world. It was reimagining the world in terms of math. They were training their minds to think in layers, in abstraction, in patterns, laying the psychological groundwork for the very concept of algorithms. And then, there's the matter of numbers themselves that we take for granted: the Hindu-Arabic numeral system, with its elegant positional logic and the invention of zero. But its entry into medieval Europe was anything but smooth. Roman numerals had no place for zero. They weren't built for computation. Imagine multiplying with no positional value. The entire Roman system was static, designed for recording, not calculating. The adoption of Hindu-Arabic numerals wasn't simply a technical upgrade. It was a philosophical revolution. Suddenly, numbers were fluid, dynamic, relational. Zero became not a void, but a placeholder of immense power. Algorithms, as we know them, were impossible before this transition, and yet many resisted it, branding the new numbers as infidel figures, mathematics wrapped in cultural suspicion. Still, the numerals spread, not through royal decree, but through necessity. Merchants, tax collectors, architects, they all began to recognize the superior logic of the system. And as their tools evolved, so did their techniques. From there, we move deeper into the realm of algorithmic thought. Take the abacus, once dismissed as primitive. In reality, it functioned as a tactile interface for processing data, essentially a physical analog for binary switches. Each bead, each column, encoded positional value. In the hands of a trained user, it became a memory device, a processor, even a simulator. Monks were known to perform calculations faster than scribes could write them down. In this light, the abacus wasn't a relic. It was proto-digital, which brings us to the question, how far did this algorithmic mindset really go? Consider the cipher. Disks found in Renaissance Europe, often attributed to early cryptographers like Leon Battista Alberti. Though technically post-medieval, their roots trace back to encrypted religious texts and encoded merchant logs. These rotating mechanisms allowed users to substitute letters through variable shifting, an early form of polyalphabetic encryption. What if these cipher tools weren't isolated inventions? What if they were descendants of lost mechanisms once used by scribes to protect sacred formulas, legal records, or even esoteric knowledge forbidden by the church? Hidden inside these practices was a quiet revolution, the birth of information theory. Even in theological debate, patterns emerged that hinted at computational logic. Scholastic arguments often relied on nested premises, flowcharts of moral cause and effect, models eerily similar to the branching logic trees of modern code. And then there's the question of memory. Medieval scholars weren't just solving equations. They were training their minds to function like machines. The art of memory, ars memoriae, was a formal discipline. Practitioners like Giordano Bruno and Ramon Llull built entire mental architectures to store and retrieve vast bodies of knowledge. They didn't write it down. They compiled it internally, using imagined rooms, pillars, and symbols as access points. It's no coincidence that Llull's diagrams resemble flowcharts. You begin to wonder, were they just inventing aids for memory, or experimenting with something closer to cognitive programming? Across regions and religions, the same themes emerge: repetition, abstraction, recursion. In monastic chants, in Islamic geometric design, in the iterative logic of scholastic debate, we see patterns unfolding, algorithms hidden in plain sight. And perhaps this is the most astonishing realization of all. The Middle Ages weren't a void between classical brilliance and modern technology. They were the bridge, a hidden scaffold of ideas passed through parchment, scroll, and chant. They were the silence before the algorithms sang in silicon. And though the scholars of that era never touched a keyboard or wrote a line of code, they laid the groundwork for the world we now inhabit. They taught us to think in systems, to encode the infinite in symbols, to trust the pattern even when the outcome was uncertain. What else have we forgotten? What if the algorithms of the future are buried not in code, but in ruins, in scrolls, in the forgotten rooms of monasteries where numbers once danced with divine purpose? The past isn't gone. It's encoded, waiting, asterisk if this journey reshaped the way you see history. If it made you question what else we've forgotten, then let it be the beginning, not the end. Subscribe to uncover more hidden truths buried beneath official history. Like if this exploration opened your mind. Comment with the questions that keep you up at night. And share this with someone who still believes the past has nothing left to teach us. Because the future isn't just coded in algorithms, it's written in memory. And memory is everything. The further we peer into the past, the more we realize nothing truly disappears. Ideas merely change form to what became of those medieval algorithms. The scrolls filled with tables, the patterns sung into memory, the geometries etched into cathedrals. They didn't vanish. They mutated. Some evolved into the backbone of modern finance. Techniques for calculating interest, developed in monasteries and merchant guilds, became the foundation of today's global economic systems. What was once a monk's moral dilemma, how much is too much profit, is now a high-frequency algorithm determining stock prices in microseconds. Others survive through accounting, a field often dismissed as mundane, yet born from mathematical precision. The double-entry bookkeeping system, first appearing in the ledgers of 13th century Genoese merchants, laid the groundwork for modern databases. The medieval ledger wasn't just a financial record. It was a logic table, complete with if-then outcomes, balancing equations, and redundancy checks. It was the forerunner of structured data. Even the concept of error checking has roots in medieval manuscripts. Scribes developed elaborate marginalia and checksum-like methods to ensure accuracy in copying sacred and scientific texts, an analog version of modern code validation. But perhaps most surprising is how deeply medieval logic is embedded in modern computing itself. Take decision trees, recursive functions, or symbolic representation, all ideas that echo the scholastic methods used in cathedral schools and Islamic madrasas. The medieval mind didn't separate mysticism from mathematics. It embraced complexity, duality, paradox. It reasoned through systems of contradiction and synthesis. In fact, some of the earliest mechanical calculating devices, like John Napier's bones or Wilhelm Schickard's calculating clock, were inspired by diagrams and proportional logic, first explored centuries earlier in monastic texts. These weren't just curiosities. They were stepping stones that today's artificial intelligence algorithms function on layers of abstraction. But abstraction itself, thinking in symbols instead of specifics, was forged in a world of parchment and ink, not plastic and code. Even the earliest forms of encryption, used in war, diplomacy, and religion, have precedents in medieval cryptology. Techniques like substitution ciphers and steganography were actively developed to protect royal messages and sacred texts. And some believe that entire texts, like the Voynich manuscript, may be encrypted remnants of knowledge systems we know. Longer understand when we speak of ancient math, of lost algorithms, we're not talking about outdated curiosities. We're talking about a vast ancestral code base, still running, still shaping. But what does that mean for us here in the digital age? It means we own more than we realize. The very architecture of your phone, your social feed, your banking system, none of it appeared from nowhere. It stands on layers, on the minds of anonymous monks, forgotten scribes, Muslim polymaths, Jewish mystics, and merchant accountants who lived and died in a world lit by fire and logic. They couldn't see the world we live in, but somehow they dreamed it, and there's something deeply human about that. This desire to reduce chaos to clarity, to find the number beneath the surface, the pattern beneath the noise. In medieval times, that search was spiritual. Today, it's often scientific. But the impulse is the same, that we're still writing algorithms, still encoding the world, and perhaps we've only just begun to rediscover what the past encoded for us. There are libraries yet unread, manuscripts yet decoded, ciphers that whisper across time, waiting for someone, maybe you, to recognize them. And so, as you go back into your world of machines, remember this: before the machine, there was the mind. And before the mind had silicon, it had soul. Let's not forget the minds who shaped the invisible architecture of our world. Without electricity, without networks, without even numbers we now take for granted, they left more behind than formulas. They left foundations. Asterisk if this journey reshaped the way you see history. If it made you question what else we've forgotten, then let it be the beginning, not the end. Subscribe to uncover more hidden truths buried beneath official history. Like if this exploration opened your mind. Comment with the questions that keep you up at night. And share this with someone who still believes the past has nothing left to teach us. Because the future isn't just coded in algorithms, it's written in memory. And memory is everything.